Okay, in this video, we'll be graphing numerical sequences, both geometric and arithmetic. And from the looks of it, we're given a table, so we're going to be plotting the points from that graph first. That would be the best thing to do. So let's go ahead and plot these points. So the first value is 1 and 10. So find 1 and 10, just put an X there. Next one is 2 and 2. So this will just take a second to do. And then I have 3 and 0.4. And I think each one of these little tick marks is worth 4/10. So now if you look at these values right here, these are very, very small. So things start going right just barely above 0. So what I'll be doing is just going right above the x-axis there, and I'll just be putting some tick marks there all the way out to 10 because it never crosses 0. It just rides along the top of 0. Now what you want to do is take your straight edge and just connect all those dots together, all those points together. Now when you look at that, I don't know if you remember this from earlier this year, but we have this classic hockey stick shape. And if you remember, that is also the classic shape of an exponential equation. So exponentials and geometric sequences, they have the same graph. So this is a geometric sequence, and it has the same shape as an exponential equation. So that's kind of something really good to remember. So from now on, when you think of geometric sequences, you can also think of exponential shape, that classic hockey stick. So when you see that shape, that's a dead giveaway that you have a geometric sequence. All right, now the next thing we're supposed to do is find the explicit form. We need to find A1. A1 will be the first member of that sequence, so A1 is 10. Now we have to find R. Now R, you choose one, and you have to divide by the one before it. And I'm going to write this as a fraction, so we choose 1, divide by the one before it will be the denominator. So if I choose 2, I need to divide by 10, that will give me 0.2. And if I move up 1, if I choose 2 and I divide by 0.4, there we go, 0.4 divided by 2, that's what I want to do. That will also give me 0.2. So I get that same number for 2 of these, so that means the R factor on this, or the common ratio, will be 2. Now remember, the general sequence of this is A1, or the general form for this is A1 times R raised to the n minus 1. We know A1 is 10, R is 0.2, and we raise that to the n minus 1. So that is the explicit form for this. So I'm going to go ahead and write that in there. Just barely have enough room to write it. Okay, we have a second problem here that we're going to do. And again, we're going to begin by plotting the table of values. Our graph is just a little bit different. So we start at 1, we go up to 10, and I think these count by 2s. And then from 2, I go up to 18 and then drop down 1 to get 17. 3, I get to 20. There's 24, count by 2s. 4, I start at 30. And I go up to 32, I drop down a half to get to the 31. 5, I go up to 38. So there's 30 plus 2, 4, 6, 8. 6, I go up to 42, 4, 6, 8. 2, 4, 6, and I drop down 1. I don't think I did that one right. I don't think I counted it right. Yeah. So let me erase that one. So I start at 40. There's 2, 4, 6. I drop down a half. And then now 7, I go up to 50. And then each tick mark's worth 2. So I go up 2. So there's 52. And it's easy to see that this is a straight line. So I'll put my straight edge there and I'll draw my straight line. So there's something here that's important that needs to be pointed out, is that when you have a straight line on a graph and you're doing a numerical sequence, that is a dead giveaway that you have an arithmetic sequence. So that should also give you an indication what your explicit form should look like. And arithmetic sequence has a linear shape, whereas the exponential has a hockey shape. So a straight line is linear shape, and it coincides with arithmetic sequence. Now we'll go ahead and write the numerical sequence for this. We know the general form for a arithmetic sequence is d times the quantity of n minus 1 plus a1. We can see that a1 is equal to 10. Now we just need to find d. Now to find the common difference, d, we choose 1, and then we subtract the one before it. So I'm going to go ahead and choose 17. I'll subtract 10. Doing the math there, I get 7. Now I'll choose 24. I subtract 17. I also get 7. So D definitely is 7. Now I'll go ahead and write my arithmetic sequence, the explicit form. D is 7. I have n minus 1 in parentheses, and my a1 is 10. So there we go. So that's an arithmetic sequence. So 7 times n minus 1 plus 10. There we go.